Good day everyone. We're going to take a look at two exercises which might pose a problem to some of you. I've already elaborated on them in this presentation. So let's take a look at 15D and E, and afterwards we're going to take a look at 23. First, 15D. Brian says that quadrupling corresponds to an increase by 400%. What mistake has he made? And I think for this kind of exercises, it's very it's a bit more clear if you're going to use a numeric example, because at first hand you think that quadrupling really does correspond to an increase by 400%, right? Quadrupling means doing something times 4. So why doesn't that lead to an increase by 400%? Well, take a look what I've done. Let's say we go from 4 to 16. That means we're going to do 4 times 4, right? So it is a quadrupling. Now we can still calculate the percentage increase, right? Using new minus old divided by old times 100%. And as you can see, that doesn't add up to 400%, but the actual answer is going to be 300%. How does this happen? What you should know, if we have an increase of 100%, 100% increase doesn't mean it stays the same, right? That means it's getting doubled. So 200% means tripled, and 300% is going to add up to being quadrupled. So for example, at exercise E, what is the percentage increase? If you wanted to calculate it, again, use a numeric value. If you go from 4 to 12, that means you're doing it times 3, tripling, right? So new minus old divided by old times 100% leaves us with a percentage increase of 200% and not 300, which you might think of, right? That was 15. The last one I would like to discuss is going to be 23. Read the question for yourself if you'd like to. It's quite a long one. What I'd like you to do is calculate the percentage decrease of members of the sports club ATC over a certain period. And each period has its own multiplication factor that you have to calculate. It also has its own percentage decrease. So the first what you're going to do is convert all those percentages into multiplication factors, right? To the right, I have given you an example how you could do that. 100 minus 7.2% is 92.8%. Dividing this by 100 leaves us with the multiplication factor. So it turns out for 7.2% it's this number, for 5.8 it's this number. And for 11.2% decrease, we're going to end up with 0.888 as a multiplication factor. If we now want to know the percentage decrease over that period, we're going to multiply those 3 multiplication factors, which will give us a decrease of 0.776. But remember, they don't ask you a multiplication factor, they ask you a percentage decrease. So now you have to convert this back to percentages again. So you can do this 2 ways. What I've done, I first converted this into percentages, right? 77.6%. But remember, this is not the decrease, this is the number that you end up with. So to calculate the decrease, you do 100%, which you started with, minus the 77.6%, which you end up with, and that gives us the decrease, which is going to be a total of 22.4% decrease, and that's your final answer going to be. I think this is pretty difficult, and I don't think the book explains this pretty well, so that's why I give you an extra example of this kind of exercises. And I think exercise 22 is also all about this, so try to do that one as well if you find this one difficult. Good day to you.